Hi, everybody. For our project, we are building a data platform for the standardization of data and identification of trends between zoonotic diseases and beef production, which is our main objective. And our motivation is that we want to establish a single source of truth for comprehensive and standardized data relating to zoonotic diseases. This is because this data is often siloed, which makes it difficult to analyze, as researchers often need to start with aggregating and preparing the data for analysis. This platform will then allow easy analysis of data. And the methodology for the platform, we use data pipeline, which uses Python class that arranges functions that extract, transform, and load the data. And this pipeline cleans, aggregates, and enriches the data with additional sources. For the predictive model, we use a logistic regression, which classifies our outbreaks, and it's using variables such as humidity, precipitation, and hot days. And for identification of trends, we use descriptive statistics, and we show that those in graphs that we are using in our interactive dashboards. We also use geospatial analysis to compare different locations in terms of the disease prevalence.
Yes, as Akhona mentioned, the data platform hosts multiple views, such as quarterly and yearly data sets. So this is aggregated on those levels. So quarterly is important to track seasonal trends, while yearly is important for long-term planning and policy decision making. Furthermore, the data platform hosts the predictive model. As previously said, it's a logistic model that was applied to the South African map, as you can see on the right-hand side. The model achieved a 91% accuracy with a minor misclassification of the class 0. And the model revealed that for every one temperature increase the odds of an outbreak reduces by 6, while for every 1 unit increase in humidity, the odds of an outbreak increases by 12%, while every 1 unit increase in historical outbreak increases the odds of an outbreak by 15%. And then lastly, the data platform will then host the geospatial analysis, which is geoplots. So as we can see from the geospatial analysis, KwaZulu-Natal had the highest number of outbreaks, which was followed by Mpumalanga and Limpopo. The middle graph then illustrates the two municipalities that contributed the highest to the outbreaks in KwaZulu-Natal, which is Nongoma and Jozini. And then lastly, it was revealed that there's a high correlation between humidity and disease prevalence, specifically in KwaZulu-Natal, which has such high humidity, as we can see from the logistic regression results. And then lastly, we'll just quickly discuss the predictive models validation. So as we can see from the left graph, the data was highly skewed to the right. The middle graph just illustrates the logistic regression's ROC AUC of 91%. And then lastly, the right graph just displays the confusion matrix and the specific metrics that follow. So overall, the model did perform quite well. Thank you so much.